This next video goes over the different types of concentration units. In chemistry, we can't just rely on terms such as concentrated and dilute to describe the amount of solute in a solution. We have to be more specific. So the three major types of concentration units we're going to cover this semester is percent by mass. The second is molarity, which many of you are more familiar with. And the last is molality. So we're going to go through each of these and do some example problems with each of these different types of units. The first is the percent by mass. And percent by mass is the grams of solute over the grams of solution times 100%. So if I have a 30% sodium chloride solution, this can also be interpreted as 30 grams of sodium chloride solid over 100 grams of sodium chloride solution times 100%. Remember that solution, for a sodium chloride solution, this would consist of NaCl and water. That word solution indicates that the solvent is water. Otherwise, another example is if you say aqueous solution, then we know the solvent is water. So let's go ahead and apply this to the following problem. We have an aqueous solution that contains 167 grams of copper 2 sulfate in 800 mils of solution. We're given the density of the solution in grams per mil, and we want to calculate the percent of copper sulfate by mass. So let's first write out our equation. We have our grams of copper 2 sulfate, over the grams of copper 2 sulfate solution times 100%. This will give us the percent of copper sulfate by mass. If we look carefully at the question, are we given any of the information that we need for our formula? Yes. If we look at this, we are given the grams of our solute, so we have our numerator. Half of the problem is complete. So we can put to the side that we have 160 grams of copper 2 sulfate. Now what we need is to get the grams of solution. In order to get the grams of solution, we have to take this volume of the solution and use the density to get our grams. So if we have 820 mils of our copper sulfate solution, and we're given the density of the solution, we can say that for every 1 mil of copper sulfate solution, we have 1.195 grams of copper sulfate. So the grams ends up being 980. So we're going to divide that by 980 grams of copper sulfate solution times 100%. So this ends up being 17.0% copper sulfate solution by mass. Okay, so that is percent by mass. If we go to our next unit, molarity, which you've learned from Chem 110, it's the moles of solute over the liters of solution, and we represent that by a big M. Molarity compared to in contrast to percent by mass and in contrast to molality is temperature dependent. Okay, it's going to be, the volume of the solution will change according to what temperature the solution is at. So for example, if I have a graduated cylinder, okay, and in this graduated cylinder, I have a certain volume of my solution. Under higher temperatures, the volume of the solution will tend to expand a little. So the volume will appear to be higher than it is at room temperature. At a lower temperature, the volume of the solution will tend to contract. So you may see a smaller, or read a smaller volume than it should be. So higher temperature, the volume of the liquid will expand, so you may have a slightly higher volume, and this can lead to a smaller molarity, versus lower temperature, you're going to get a smaller volume reading, and your molarity will be higher. Okay, so molarity is dependent on the temperature. Let's go ahead and apply this to another problem. In this problem, we're asked to get the molar concentration of a solution of sodium bromide, given that we have 10.3 grams of sodium bromide and 251 mils of solution. So let's write out our formula. We have moles of sodium bromide over the liters of sodium bromide solution, and that will give us our molarity. The molar mass of sodium bromide is 102.9 grams per mole. We are already given our volume of the solution in milliliters. We just need to change it to liters. So if you change it to liters, we have 0.251 liters of solution. Now we just need to get our moles of sodium bromide, so we're going to take the mass of our sodium bromide and we're going to divide by the molar mass, which is 102.9. So the moles of sodium bromide ends up being 0.100 moles. So we have 0.100 moles of sodium bromide over 0.251 liters. The molarity ends up being 0.398. Okay, and our last unit of concentration that we're going to go over is molality. Molality is moles of solute over kilogram of solvent. So if I say I have a 2.00 molal solution of sodium chloride, okay, we represent molal with the unit of a little m. Compared to molarity, that's a big M, but for molality, it's a little m. So this can also be interpreted as 2.00 moles of sodium chloride. By the way, this is sodium chloride solution. So 2.00 moles of sodium chloride per 1 kilogram of water. Okay, so students often get confused that molality is not per kilogram of solution, it's per kilogram of solvent. And molality is temperature independent. because we're measuring it through the mass of the solvent, and the moles and the mass of the solvent are going to be in a ratio. So molality will be temperature independent. So key thing, it's moles of solute over kilogram of solvent.